Hello and welcome to another episode of the Clojure Pills screencast. This is episode number 14 and the function we're going to see is the get function. As usual, a quick update about the book I'm writing for Manning. The content of this screencast is roughly based on the content of the book. So if you enjoy the screencast, you might very well enjoy this book. There is still ongoing the discount code 42% on the price if you enter the code that you can see on the slide, and you enter that code when you buy the book and the website that is also displayed on the slide. And below, if you have any question, there's my Twitter handle at reborg, or also my email address, which is reborg@reborg.net. So get, quite a simple function. It's a function mainly dedicated to associative data structures, so key-value maps, so especially maps, but not only. Also sets and vectors are associative and in Clojure. The value is associated to their index. But maps is probably the most common use case when you see get used in the wild. It takes two arguments, the map and the key, and it returns the value found at the key in that map. There is also another arity that takes an additional or optional third argument, not found, and that can be used to return the not found value when the key is not found in the map. So let's have a look at what we can do with get. So as said, it works definitely on hash maps. All right, everything is working fine. So you can see this typical example, get from a map with two keys. I'm getting the A keyword key and is returning the string. Nothing surprising here. It also works on other kind of maps, always maps, but other kind, like transient maps. Transients is the mutable version of a map or other Clojure data structure, and they usually don't work very well with all the, not that they don't work very well, but they are restricted in use and they don't work with many of the functions on the standard library. But get works perfectly fine with transients. Sorted maps, very similar thing. We are just asking get to return a key from a sorted map and is always returning the value as expected. We can see an use of the not found optional parameter. Now we are asking for a key that is not in the map, and simply the message is returned. You can return any other object, literal or any other thing. One thing that distinguishes get from other ways of making access to maps is the fact that get is resilient to nils. So it doesn't throw exception, it just accepts to get from nil, and it usually returns either nil, or if you provide the default value, it will return the default value instead. And you can go wild with this, and you can get nil from a nil map and still it works perfectly fine without throwing exception. Other accessors like nth for vectors will instead prefer to throw exception in this case. So I said it can give access to many data structures, not just associative data structure. Let's have a look. It works probably mostly the same, so I can get from a set. The difference is though that the meaning of getting from a set is different from the meaning of getting from a map. So when I get a key from a set, I'm actually returning the key itself, and the meaning of this operation is containment. Get is telling me that the element is existing in the set and is returning it. It would return nil if the element is not present instead. It works fine with sorted set, and we can see also that it works with vectors, and other kind of vectors like transient vectors. Again, the meaning in this case is making access to an indexed value in the vector. So values are indexed zero based, starting from left to right, essentially, from the beginning of the vector. And when you do access the vector with the number 1, you get what is the index 1. That also means that you don't get meaningful value if instead of making access to a number which is a valid index, you make access to something which is not a valid index. So still get works properly in the sense that it doesn't throw exception, but is returning nil. And this nil that can then be interpreted only if you know the kind of collection you are trying to make access to. Then we've seen just a few of the things that get can do with the normal data structure, but what else? Well, we can see that it works with strings, so it's making an indexed access to the array of characters represented by the string. It can make indexed access to native arrays in a very similar way to what happens with vectors, so no surprises here as well. It works with def records, so if we define an address record with 3 keys, we can then use get to make access to one of the keys. Of course, the record and hash maps in general will work also if you use the key itself to access the map, or the map itself, or the record itself. I'm not sure about this last statement, so I'm going to check with you. What happens if I do this? No. Alright, so def records are not implementing the IFN interface, so they cannot be used as functions, but you can definitely do the opposite, which is using the keyword as a function, which is supported, and return the key. So what I mean with this is that get is equivalent in use at making access to the map with the map itself or the keyword, but it gives you the option of so it gives you the flexibility, the added flexibility of passing a nil or using a nil as a key for those cases in which you don't know what you're getting, and you don't want necessarily to use an explicit condition to say if there is a map here, then use get. One last case, it works on native hash maps as well, so you can use get on a hash map that is created from a clojure map, and that will return as expected the value at the key. So it works for many things. It means that the best use cases for get are where you don't have precise control over the parameters that are passed to you, that they can be a map of some kind. There could be a native map, there could be a clojure map, or they could be nil, and you don't want to necessarily have to code up all the conditions in order to access the map in the best possible ways. If you use get, you are getting most of the use cases for free. Most of the exceptional cases are handled for you for free. There is some surprise, as usual. So that the definition of surprise really depends. It might be surprising to see this, that you try to get from a list the number 1. You might be tempted to say that it works as a vector, but it doesn't, simply because sequences, lists in this case, are not supported by get, and the way get is telling you this is just by returning nil, so it's not throwing exceptions. So you might need to pay some attention if you are doing processing of vectors with sequence functions that are transforming the vectors into sequences, and then you're passing them to get. You might see a nil when the meaning of that nil is a failure, instead of properly returning a nil as a value coming from a map. This is instead something that, again, depends on your definition of what is a surprise or what is not a surprise. So we saw that we don't have problems with transient maps, but there is a bug regarding transient sets instead, and transient sets are not working. So this is surprising, but at the same time is a known bug, and it will probably be fixed at some point in the future. So it's just good that you need to remember though that transients are working in almost all cases, but not in the set case. So as you can see, it's not throwing exception, it's returning a nil, but this nil is not to say that the element 1 is not in the set, it's to say that this is one of those cases that get is not implementing, so it's a bug, as I said. Another thing that might be surprising is there are many cases in which get is just returning nil and not throwing exception, and you're, even in this case, you're passing a default value not found, so you would expect a nil, or at least I would expect a nil, but this is returning a class cast exception, but it's not dependent on get. This is more the semantic of sorted maps and sorted sets. A read access operation on these sorted collections still requires to compare the key and descend a balanced tree to find where the value for the key is. For this reason, Clojure doesn't know, with this implementation of sorted maps, doesn't know where to find this key, because it cannot be compared with the existing keys. And the reason is because you cannot compare, in this case, symbols and keywords. But it would happen the same with numbers and keywords, or string and keywords, and so on. So if there is no comparator for what the keys, the type of the keys is, and the key that is making access to, then it will throw exception. As I said, it's a borderline case. Could be considered a bug, or it could just be considered a case of garbage in, garbage out, since the semantic of sorted maps is well specified. This one is also borderline in the sense that is a surprise that you throw in a giant number like that and you get one of the elements of the vector. And the reason is because the implementation of get inside is making use of int value called on a long, which is this big number here. So when the int get cast to a long, there might be a loss of precision, as it's happening in this case. We are losing precision, and instead of returning, for example, exception because we cannot cast it, it is accepted with the loss of precision, and this number cast into an int value is 0, and that's why it's getting full access to the vector at and returning the number 1 at index 0. So, and again, another borderline case, it might be considered garbage in, garbage out, but there's no documentation or any other signs, any other warning that can tell you that you're passing a too big number and something dodgy is happening in this case. So things to keep in mind in terms of possible surprises. Typical use. I want to present a case that is typically found, and it starts here after the surprises, here where the typical use is. And since we mentioned the fact that get is perfectly happy to use native Java maps, there are a couple of cases of native Java maps, and one of them is that are currently used in Clojure as Java interop, and are those related to the two system maps, get the properties map and the environment map. And you can use get in order to access these two maps without problems. And what I'm showing here is like a more interesting use where the two maps, the properties and the environment, are mixed together, and then it is executing a fuzzy search using the key as like one of the part of the possible key to find, and it's filtering the keys that are matching that pattern, and it's returning the results in a proper closure map at the end. So if we evaluate this and we have a look at what's happening, we can, for example, search for dir, and we see all the properties or environment variables that contains the word key in their name. So temp dir, endorsed dirs, external dirs, and so on and so forth. And just to show you how the system properties map looks like, is something like this, with like key value pairs. In this case are strings and strings, I think, both sides. And this is just making access, it's just using get here to make access to those keys. The usefulness here of using get compared to potentially other methods is that get accepts native Java maps as well as closure maps. So this function doesn't really need to care about if this is a map, a native Java map or another kind of map, and is making access to it. What else? Just a few alternatives. Let me clear the screen here. I briefly mentioned that get is one of the ways you can get a value from a map. There is also find. The difference, I mean, they're very similar. They also share part of the implementation, but the difference is that the key, if it's found by find, is wrapped along with the value in a map entry. So if we look at the type of what is returned by find, you can see that is not a vector, is a map entry. Find, though, does not support the optional value, default value, if the key is not found. We saw before briefly that you can also access the key using the map as a function, or using the keyword if you are lucky and you have keywords in the map as key. Finally, you can also use native access. After all, clojure hash map is also a Java util hash map. Is also Java util map interface. So you can use the method defining that interface to access the map. And you can see here I'm using Java interop get method to get access to that behavior of a clojure hash map. And it still works the same. There are no huge reasons to use, for example, Java interop. These other methods are much more useful, especially accessing a value using the map as a function. That is one of the things that is very welcome from clojure beginners when they start and they see they can access maps so easily just by using them in the callable position in a list, like in this case, and is very concise way and idiomatic way to access a map. So that would probably be the best choice. Then there are reasons why you might want to use get, like the one I explained a few minutes ago. There are no big reasons to make use of Java interoperability if not for speed reasons, and we're going to see a little bit of that in the performance section that is coming up. So to show you a little bit of the performance profile of get, I prepared a couple of charts. So the first one is showing get used against several type of collections. We saw a few examples of them before. So we have sorted sets, sorted maps, set, transient map, normal map, clojure maps, Java hash map, vector of, which is a vector of native types, and subvectors, and vector, essentially the family of the vectors. So I also illustrated them in order of increasing speed. So we start from the left where we have the slowest, and we go down to the right where we have the fastest. We are still talking in absolute terms of very fast operations. Those are nanoseconds. So we are talking about below 300 nanoseconds. So it's extremely fast operation to access a map. That is very welcome. Even with sorted maps or sorted sets, it's still very fast. You can see also like the performance profile of sorted collections compared to non-sorted collections. So it is a logarithmic behavior, the one you see on the left, meaning that I've used exponentially bigger collections to do this test. So I started with 100 items, 1000, 10,000, 100, and up to 1 million keys, and that is an exponential increase in the size of n, and at that exponential increase it relates a linear increase in the time to calculate, to make access to the key. So that is normally explained as a log n, big O of log n performance profile, and instead it's very close to constant access for anything else that is not sorted. And talking about very close because you know that persistent data structures in Clojure are not exactly linear. They're not arrays, they are trees, very shallow trees. So there is a little bit of logarithmic aspect into that, but it's so shallow, the tree, that it's very close to constant time. And for all the practical purposes, it can be considered constant time. But even in the case of logarithmic time, is a very good profile in the sense it's still way below linear, and that means that you can use a sorted set or sorted map and use get on sorted set or sorted map with being relatively happy about the speed that you get. Another chart is instead comparing the different ways of making access to a key in a map to return a value, and these are the ones that basically we saw in the screencast a while before. So we have get, we have find, we have using keyword as a function on top of a map. We have get on a clojure map, .get, Java interop. We have the map uses as a function, and we have again .get, but this time is just for comparison. I'm using Java interop get on the Java util map interface against using as a map a proper Java util hash map. And that is the fastest, but it's also like for comparison in the sense that it's a mutable data structure, so we are not usually using those in Clojure unless we have a specific problem to solve. For all there are the cases though, we can see still that we are talking about very fast operations. Maybe one thing that is useful to see or useful to know in this case is that making access with get is not necessarily faster than making access with using the map as a function. Actually, using a map as a function is not only a concise and idiomatic way, is also one of the fastest methods to access a value in a map. So all considered, get is useful for the kind of flexibility it gives, but in all other normal cases, common usage of Clojure, making access using a map as a function is perfectly fine and fast. So I think this was all I have for today, and hopefully you enjoyed the screencasts. More will come, although I'm not sure about the schedule, but every once in a while we'll definitely record one. What I typed at the REPL today will end up in the show notes that will be available at the GitHub project that you see on the screen right now. And I hope you enjoyed it, and until next time, goodbye.